to the topic of level of service and capacity analysis, and what we have covered up to now is the analysis for multi-lane highways and freeways. Okay, so there were three types of analysis: design, where you find the number of lanes; you have the service flow rate and service volume analysis, where you find out the maximum service flow rate and maximum service volume for each level of service; and the operational analysis, in which you find out the level of service. Two of them, the last two, you have to do it for your term projects as well. Okay. These are two types of uninterrupted flow facilities. Multi-lane highways and freeways, both are uninterrupted flow facilities. The third type of uninterrupted flow facility is a two-lane highway. Now, for a two-lane highway, I did not find the specific chapter in the book. Okay, the new edition of the book does not have a chapter or a section on two-lane highways. Okay, it has chapters on urban streets, which should cover two-lane highways as well. Okay, but not specifically. It's not written, okay, two-lane highway do this. Okay, so what I did, I went to the highway capacity manual. Okay, and then there is a whole chapter about two-lane highways. So what we will discuss now is part of that chapter. Okay, so it's not from the book, it's only from the manuals. In the book you will not find two-lane highways. Okay, if you go to the manual, you will find chapter number 15, which is about two-lane highways. The whole chapter is about two-lane highways. Okay, and it has more details than what we will discuss in the class. It has many more details. I'll show you some part of it. Okay, and I will tell you what is more. Okay, but in the manual, again at the end of the slides, you will see the questions which you can do. They are also from the manual. Okay, and some of those questions are for solved examples. So they have done complete solved examples as well from start to end. Okay, so do go through them. Okay, because what we are doing is only a small part of it. Okay, and why we are doing a small part? Because of the details which are not important for the sake of the class. Okay, we are still on this silo, this outcome. Okay, so two-lane highway means we have one lane in each direction. So these highways are unique from the other types, from the freeways and multi-lane highways. Okay, what are their unique characteristics? First of all is the passing. Okay, on a multi-lane highway, on a freeway, you have multiple lanes in your direction. So passing is easy, because if you have somebody and you want to go fast, okay, but that guy has nothing to do in his life, so he is chilling. Okay, even this weather. Okay, so what do? You go to the other lane and you pass, right? Okay, you can do pom-pom and this and so you can do everything. Okay, but you don't have to go in front of them. Some of you would like to, I know. Okay, let me go in front of them, show them. Okay, but it's not necessary, right? It's not necessary. Just then this lane also belongs to you. Okay, so passing is relatively easy. One lane only. One lane change required only. Okay, and that lane change can be done slower as well, no problem. I can go faster later on, right? To go in the other lane, I can go slower as well, no problem. Okay, because there is a car, I can let this car pass and then go to the other, right? So I can go faster, I can go slower, and I just need to do one lane change. Okay, but for two-lane highways, this is not the case. Okay, because for passing, you will go where? In the opposite direction. Then one lane change is not enough, obviously. One lane change is not enough. You have to make one and then come back through. Okay, and that lane change has to be faster, because then what's the point? If you are doing it slowly, you go to the other lane and come back, and that guy is still in front of you. Okay, get my point? So you have to make more lane changes and you have to do it faster. Faster, well, yes, you want to take over this guy, but faster for the other traffic as well. You want to get out of the way as fast as possible. So high speed and more lane changes. Okay. So passing is more difficult on two-lane highways and more risky as well. Okay, it has more risk. Yeah, and another thing which I mentioned in the last topic as well, two lanes are right beside each other. Anything which is beside you affects you in terms of driving, whether it is moving or stationary. Okay, if it's a concrete barrier, still it affects you. If I remove the barrier, your driving behavior can change. Okay, if you remember in the analysis we were doing in the last chapter, you were taking lateral clearance and lane width. Why? Okay, because your width also affects you. Okay, what is happening on your side affects you. Okay, so that's why. So on a two-lane highway, again, multi-lane highway, freeway, you may have a shoulder, you may have another lane and so on. Okay, but on two-lane highway, you have your lane and the other lane is beside you. So you have traffic going in one direction, traffic coming from the other direction. They are going beside each other. Okay, so one direction has definite effect on the other side. It is not like it may affect. No, it will affect. Okay, so you have the effect of the other direction as well. On two-lane highways, sometimes we give temporary lanes. So it's two-lane. It's basically two-lane. The default is two. Okay, but we know that there can be heavy vehicles. There could be some problem at the road. Okay, so we may give a short temporary lane. Okay, and that short temporary lane can be used for passing or truck climbing. You're not climbing on the truck. Okay, nobody is climbing on the truck. The truck is climbing on the gradient. Okay, so you have a gradient going up. Now you know if the truck is going in your lane on this gradient, it will go slowly. Okay, the cars can go faster. So you give an extra space to the truck so they can go into that lane until they pass the gradient and the cars will move faster. Okay, so climbing lane is for that, and passing lane, you know, passing lane, so to make the passing safer. Okay, so you don't have to go to the other direction, you have an extra lane on your side, but only in a short distance. Okay, if you go after that, the passing will be from the other direction. Got it? There. Okay. Yeah, in some cases you can have the lane which is alternating. Okay, so you can have a 2+1 arrangement as well, where you have a continuous lane in the middle. Okay, which is used for passing from both directions. Okay, but the default is still two lanes. What are the base conditions? Base conditions means ideal. Okay, the ones which will give you the best performance. Okay, so what are those conditions? Lane width 12 feet, lateral clearance 6 feet. These are minimum values. More than that, more than 12, still the same result. Okay, all traffic is composed of passenger cars. Okay, so what is the other type then? We have passenger cars, and the other types of vehicles are which one? Heavy vehicles, right? Okay, so no heavy vehicles. Level terrain, alignment is straight, so no horizontal curve, and yeah, okay. If the horizontal curve is there, the horizontal curve is very, very large. Okay, so this is an ideal condition. No impediment, meaning no interruptions, no intersections. Okay, we already talked about it. Yeah, it could be an intersection, or it could be just an entry point, an access point. Okay, so ideal condition is none of that. Good environmental conditions, the road, the weather is clear, the road is fine, and so on. Okay, so these are all ideal conditions. When you achieve them, you have the best performance on in terms of traffic. Okay, some examples where we can use two-lane highways uninterrupted. Remember, you may see lot of two-lane streets. Like even inside the campus, we have a two-lane street, right? The road which is going around the campus is two-lane. Okay, but you cannot deal with it here because that one is not uninterrupted. Okay, and uninterrupted means what? It does not have intersections. And what was the condition when highway with intersection can be uninterrupted? What was that condition? 2 miles. 2 miles. Okay. Then the intersection is more than 2 miles. Obviously, this highway has intersections, and these intersections are very close to each other. Okay, so that's why it cannot be uninterrupted. So where 2-lane highways can be uninterrupted, this is the example of that. So mainly you will see in all of them, you can read it later on, you will see when they are outside the city. Okay, 2-lane highways outside the city are normally uninterrupted. Because they are outside the city, the traffic is low, so we only need 2 lanes. And because they are outside the city, there is no crossing, right? Crossing from what? There is nothing. Okay? You are going from one city to another city, one city to maybe an industrial area, a city to a beach, a picnic area or something like this. Then you can have a 2-lane uninterrupted highway. Okay. The segments of a 2-lane uninterrupted highway can be of 3 types. We have passing constrained, passing zone, and the one which has an climbing or passing lane. Okay. The first 2 types only have 2 lanes. The first 2 types have 2 lanes. Okay. What is the difference between them? What is the difference between this and this? Huh? No, both of them are uninterrupted. Their intersection, they are more than 2 miles, and all of them. What is the difference between these 2? The difference is passing is what? Here passing is not allowed. Here passing is allowed. Okay, and it is mainly because of side distance. Okay, side distance is not enough for passing. I cannot provide an extra lane. I cannot do anything with the side distance. Okay, passing is not allowed. Okay, so you see we put a signboard for passing not allowed, or they put a white line between the lanes. So this is all passing constraint. And the third one has an extra lane. Passing is allowed, but from the extra lane. Clear? Okay, so the difference between the first 2 and the third one is the extra lane. Okay, and the difference between this one and this one, both of them passing are allowed. But here passing can be done from the same 2 lanes. Here passing will be done from the extra lane. Okay? Okay. Access points I mentioned last time as well. Last 2 lectures. What do we mean by access points? What is an access point?
There is an in and out.
In and out. Which direction? Right or left?
Right?
Right only. Okay, in and out, right only. Okay, and it should be without signal. Okay, so no crossing and no signal. Okay, that's called an access point. Okay, so you have to count how many access points you have on your segment, and then you can know their number. Okay, yeah. If the access point is to a garage, okay, from the garage, maybe one vehicle will come out in the whole day. Okay, so that you can avoid. Okay, any access point which has less than 20 vehicles per day can be ignored. Don't count it. Got it? Any access point more than that should be counted. Okay. If if you have some solid median, if you have a solid median between the 2 directions, then access points for each direction will be counted separately. If you have a solid median, so I cannot cross. Okay, so I cannot cross for access points. For this direction, they are 10 and they are 5 here. So for this direction, I will take 10. For this direction, I will have 5. Okay, but there is no median. 10 plus 5. Got it? Clear? So both will be combined. Okay. To know the level of service for 2-lane highways, I need to know these things. Okay. What is the first one? You already know, right? What is the first point? Free flow speed. Okay. So we already know about it. We have seen some equations. I believe there is a different equation here for free flow speed. Okay. Average speed we also know, right? Average speed we also know. Average speed of the vehicle or the then. Okay. Now what is the difference between free flow speed and average speed?
Free flow speed when the traffic is low.
Okay. And average is?
Normal.
It can be. Okay. If you are taking average when the traffic is low, then that will become the free flow speed. This is what you are doing in the term projects, right? I asked you what? Collect traffic data or collect speed data and do the average, right? That is average speed. But if that average is taken in low volume conditions, that becomes free flow speed. Okay? Okay. So these two we know. Then we have person followers and follower density. So you need to understand the word follower. Okay? What do they mean follower here? Okay? Not the Instagram followers. This is different. Okay? Not this. Okay. So follower means the person who is so close to you that he has to follow your acceleration and deceleration. Otherwise, he will get an accident. Okay? So the spacing between you and that guy is so less that he has to follow you in terms of your acceleration. If you apply the brake, he doesn't have time to go in the other lane or do something else. He has to apply the brake. Got it? Okay. So how close is considered a follower is 2.5 seconds or less. Then the headway between, we call it the headway. Okay, the headway between the two vehicles is 2.5 seconds or less. This comes under the category of a follower. Okay, so this is a very small time window, right? Somebody applies the brake, you don't have enough time to do something else. You have to, first of all, you have to slow down. Later on, you may get the chance to pass and do other things. Okay. So this person, which this much headway is considered a follower. Okay. So if you have 1,000 vehicles in traffic, what percentage of those vehicles are in this condition? This is called person followers. Okay. Out of the total traffic, how many of them have a headway of 2.5 seconds or less between them? These are called as person followers. Okay. Clear? What is density? How do we define density? Volume over? Volume over what? Mile? Not volume. What over mile? Half answer is correct. Huh? Vehicles over mile. Okay. Volume is vehicles per hour. Okay. VV. Okay. Vehicles over mile. Vehicles per mile. Okay. So you will have 1,000 vehicles on the road. So 1,000 per mile, right? 1,000 vehicles are on the road. So or let's say 30 or 50 vehicles on the road. 50 vehicles on the road. So your density is 50 per mile, right? 50 per mile. Maybe not all of them are not in the follower state. All of them may not be in the follower state. Okay. So for example, I found person follower to be 50%. So out of the total vehicles, 50% are in the follower state, right? So what will be the follower density? 50% of the actual density. What am I going for? Okay. So person follower is how many are in the follower state, and follower density is what is their density per mile. What is their number per mile? Okay. And both of them are calculated from each other, as you can see there. Multiply the density with the percentage. You get the follower density. Okay. Maximum flow rates for on a passing lane. Okay. If you have segments which have passing lanes, then this is the maximum flow rate you can have. Okay. This is percentage of heavy vehicles. We know that. Okay. These are the flow rates. Okay. This is what they call as a vertical class. Okay. Right now, these are just codes. We don't know what 1 means. We don't know what 2 means. We don't know what 3 means. Okay. This is a code given according to the terrain of the road. Okay. So 1 is a code given to a specific terrain of the road. 2 is a code which is given to a specific terrain of the road. Okay. Clear? Okay. So 1 and 2 and 3 means the road profile is changing. What is changing? The road profile. Okay, so depending upon percentage of heavy vehicles, and this you can get the maximum flow rate. Okay, and the good thing here is no conversion. You see, the units are what? Vehicles per hour. Okay, so you can get the number from here without converting it to passenger cars or anything. Okay. Then this is the table which gives you the level of service. Okay, so again you can see we are using two things here, follower density, no, only one, sorry, follower density, yes. So if you have a road which has a speed of more than 50 miles per hour, you will use this column. If you have a road which has a speed of less than 50 miles per hour, you will use this column, okay. And this is the level of service you have, and each one of them is a range. Each one of them is a range. Now tell me, if it is 4, if the follower density is 4 and my speed is 70 miles per hour. If the follower density is 4, my speed is 70 miles per hour. What is my level of service? BMC? How can it be BMC code? Can I say your grade is BMC code? I cannot, right? B or C? Tell me one thing. B? B?
Otherwise it would be C.
Yeah?
Otherwise would be C.
Yes. B or C?
C.
C.
C, yeah. Don't
Okay.
say.
What was it last time?
Otherwise C.
Always C.
Otherwise C.
Why are you here? Okay. 4 is here. Okay. Remember the rule. If one side is unequal, the other side is equal. Okay. So this one is more than 2, right? So equal comes here up to 4. Okay. This one is more than 4, right? So 4 has to go here. What my point? Okay. If a range is given and they write more than or less than with only one number, that means the other number already has equal with it. Got it? Clear? Okay. So they have given, we don't need to use the other table, we will not use it, but just for the sake of, so this is what I was saying, the manual has many things which we are not discussing, which we are not studying in this course. For example, they have a whole procedure to find out level of service for bicycles on a 2-lane highway. The first table is which we will use, that is for traffic. Okay. The second one, you can see, just to give you an idea what more things manual is covering. So one of those things is the level of service for bicycles. Okay. If you want to find out the level of service, you need to know these things for a 2-lane highway. You need to know the lane width, the shoulder width, how many access points you have. Okay. The speed limit, is there a passing zone or not a passing zone? Is there a vertical gradient or not? Is there a horizontal curve or not? Okay. What did you drop? And she is still going. Yeah, let's go. Okay. Is there a passing lane or there is not a passing lane? Okay. The latter half of the table is related to the demand, the volume data. Okay. So from the volume, what other things you need? You need to know how much volume you have in one direction or in each direction, however you want to take it. So you need the volume in both directions. You need the what? I don't even know that. Why? Okay. Is it? Yeah. Okay. So what is your analysis period? So you need to know volume in both directions. You need to know what is your minimum analysis period, the period which you take for your flow rate. And I told you earlier as well, we normally take it 15 minutes. okay, peak hour factor and the percentage of heavy vehicles. Okay. Now in some cases you see the default values, right? In some cases default values are given. So if it is not given, or you cannot find it out, you can pick the default value. In some cases there cannot be a default value. For example, vertical gradient or horizontal curve. It has to be a real value. Okay. And same thing here as well. Volume, you cannot have a default value for the volume. It has to be a real value. Okay. So these are the things which you need to know in order to do the analysis. And the second column they have written from where you can get it. Okay. So you can get it from the field. You can you can get it from the design plan and so on and so forth. Okay. This is the whole procedure. You can see it has 11 steps. Okay, it has 11 steps from the start to the end to find out the level of service. Okay, it's not so clear, sorry for that, but we will go through it. Okay. Okay. One thing which I mentioned earlier, I showed you in the table as well, which is the vertical class. The code which they gave according to the terrain of the highway. Okay. So this is the table which tells you the code of the vertical class. Okay. Vertical class 1 means, so we said we have 3 types of highways, right? 3 types of segments. The segments which have passing constraint, passing not allowed. Segments which have a passing zone, passing is allowed. The segment which have an extra lane for passing, right? 3 types. So in each one of them we have a different coding system. Okay. So if you are not allowing the passing, then the segment length between this to this is considered as class 1. If you are not allowing if you are allowing the passing, then the segment length between this to this is considered as class 1. So you can see the range is different, right? And passing is not allowed up to 3 miles. Passing is allowed up to 2 miles. Okay. And if you have a passing lane, then this is the length for class 1. Okay. From 0.5 to something. Okay. Less than 0.5, you have to go back to one of these. If it is less than 0.5, you have to go to one of these. Okay. Same thing for class 2 and so on. Okay, now we are moving on to the steps. Okay, first thing we do is you take the volume. Remember I told you must have the volume, right? You must have the volume for both directions. You take the volume and divide by peak hour factor. Okay, when you divide the volume with peak hour factor, what does it become? Flow rate. Okay, so first thing is convert the volume to flow rate for both directions. Okay, first step is convert volume to flow rate for both directions. Okay, so this is the coding. Okay, so the first the previous table, this one was telling you the length range. Okay, this one is telling you the gradient. There was no gradient there, right? Only length. Okay, so this one has length and gradient both. Okay, what are these numbers? These are the codes, the vertical class. Okay, this is the vertical class. For some reason they have, but both numbers are same. Okay, there.
So which one will we take? Will we take the one?
Yes, very important question. Which one should I take?
The one in the brackets.
The one in the bracket or one outside the bracket? No, but which one should I take?
There is a different.
There is, right? Okay. So the general cases, both of them are same. Okay. The only difference, which one?
One is 4 and 3 and 2, and now 4 and 3.
Which one? No.
3.
Which column? Fifth, 1, 2, 3, 4, 5. Fifth one?
Yes.
Which one here?
4 and 3.
Okay, we have this one as well. Okay, so you have to refer back to the manual and read the notes in that case. Okay, so in the table there are nodes there. Okay, we will pick the one which is outside the bracket. We'll pick the one which is outside the bracket. But what the number in the bracket is showing, you have to refer back to the notes in the manual. Okay, but the general cases you can see out of the whole table, only 3-4 values are different. The rest of the cases it's the same. Anyways, we will focus on the one which is outside the bracket. Okay. Free flow speed, you can measure it on the field, and we call it what study? Spot study. If you cannot measure it, then we have this equation or the set of two equations to find out the free flow speed. Okay, the first equation is to find out the base free flow speed. Base free flow speed is what? 1.14 into speed limit. Simple. Look at the speed limit on the road. 1.14 will give you base free flow speed. We take that base free flow speed and put it in the second equation. Okay. Now you can see in the second equation I have some factors here. Okay. Factor A, which comes from this equation. Okay. Percentage of heavy vehicles, percentage itself. If it is 2%, 2%, 3%, 3%, whatever it is. Factor for lane and shoulder width. It comes from here. Okay. LW means lane width, SW means shoulder width. The value itself in feet. Okay. The value of the lane width and the shoulder width. And then we have the factor for access points. Factor for access points. From where do we get it? From here. Okay. So what is APD? APD is access point density. So you count number of access points divided by the length. Okay. Count how many access points you have, divide by the length. An access point is which has no intersection, no signals, and no crossing. Only right in and right out. Okay, so you count how many of those points you have and you divide by the length. Okay, should I take both sides or one side only? What? There was a rule. Not always. Not always one side. Sometimes we take both sides. Which one was that? I will read this. There was a rule. Which one is it? Thank God I'm not getting mad, right? What was the rule? What was the rule? The rule was with the median. Okay? If there is a solid median, one side will do. No solid median, both sides. Okay? So you have to keep it in mind here. Okay. Now they are saying take this one or this one, whichever is better. Got it? Okay? Okay. Now the only thing is, how do we calculate the A factor? Okay. For A factor, now you can see we have in this equation A0, A1, A2, A3, A4, A5, and we have L, which is the length, and we have V0. V0 means flow rate of your opposite direction. Flow rate of your opposite direction. Now you have two directions, right? You may be, we did it in the last lecture as well. We may be doing the level of service for each one of them separately. Okay, so for this direction, you have to take this flow rate. For this direction, you have to take this flow rate here. Clear? Okay. Now from where do we get these values? A1, A0, and so on and so forth. Okay. So these values are coming from this table. Okay. What do they depend upon? The vertical class. From where do I get the vertical class? This table. What happened? Okay, so you have to pick the vertical class from here. Then you come here to this table and you will see what is your A1, A2, A0, A1, A2, up to A5. Okay, so this is what you need to do to find out the free flow speed if you do not measure it directly from the field. Clear till now? Okay. The next step is to find out the average speed. Like we had for freeways and mundane highways. Average speed could be equal to free flow speed, which is the first condition. See? Average speed or the S equals to free flow speed. When S is equal to free flow speed? When? Flow rate. Flow rate is less than or equal to 100. Now what is this? Which flow rate is this? Flow rate in your direction. Flow rate in your direction. Clear? Okay? And if it is more, then we have to go and calculate from this equation. Okay? So we need the free flow speed, we need the flow rate, and then we need two factors, right? M and P. So M is called, these are called the slope coefficients, and they come from somewhere. Okay? Huh? Yeah, we ignore them, obviously. We ignore them. Like we ignore so many things in that. We just ignore them. And they are not there. Okay, you will get an F in the exam, just ignore it. Okay, for now, I will give you the values. Okay, but again, if you refer back to the manual, like I said, there are examples, short examples given in the manual. You will see that M comes from a table. To use that table, you need an equation. To use that equation, you need another table. You need, okay. Okay, so you see where I'm going. Okay, I will give you an idea about it. Okay, the next thing you calculate is percentage followers. Okay, and again there's an equation. We have E and M and VD and P. Okay, now what is VD? It was in the velocity, right?
In my direction.
Velocity
No,
in
in
your
my
direction.
direction.
Flow rate in your direction. Okay, which is like not doing anything. Okay, M and P were those dangerous things. Okay, but to make our life even more miserable, they are not the same M and P as we saw in the previous equation. Okay, so if for example for the last M and P you solve 10 equations and 20 tables, and this one is not the same. So there are different 10 equations and 20 tables for these ones. Okay? What?
Why do you want us to suffer?
Why what? No, they don't use sensor. Huh? Yeah. What can I say? I didn't write the manual. I didn't write anything. Okay. Anyways, but to keep the point in mind is, if M and P is given, you have to see for which equation is it. Is it for the speed equation or is it for the percent follow rate?
How do you?
Huh?
You
You have to ask your stupid name. Okay, this is how you know. Okay. The other thing is you have to go in the manual, you solve it, so then you will know. After half an hour you will know.
The time will be finished.
Huh?
The time will be finished.
Like I said, I'm just telling you that why are we not going in that. By the way, to find out these things, the only thing is the time. Okay, there is nothing new. There is no, like I cannot say that to find out M and P you must know this factor about traffic. There is no new factor. There is nothing new. They are just saying, okay, go into this table, take this value, go into this equation, put this value, go into another equation. So it's just like a chain. Okay, which they have come up with after years of research. Okay, but there is no new thing here. Okay, so that's why, for the sake of the class, the values will be given. Okay, the values will be given. But I'm telling you, the values, you don't go to the manual and say where is the value for M, where is the equation for M, and where is the equation for P. There is no single equation. Okay, it's a series of tables and equations. Okay, so the second thing you find out is percentage followers from this equation. Just keep in mind, M and P for the speed equation are not the same as these ones. Okay, and what about E? What is E? Huh? Same. Huh? Somebody is trying to say something. Why are you killing me? Okay. After you find out all these things, the last step is to find out follower density. For percent follower will be, now you keep in mind, you are doing what? Calculating this, multiplying by 100. Okay. So it is already a percentage. Okay. So its range should be how much? What should be its range? It's a percentage, right? Yes.
Yeah.
The percentage goes from 0 to 100, right? Okay? Okay. Then you come here, you put the same number here. Okay? So if it was 50, you put 50 here. Don't make it 0.5 and then divide by 100 again. Okay, and then you multiply by Vt upon S. Vt was the flow rate in your direction, S was the speed in your direction. Okay, it could be equal to free flow speed, it could be something else. We saw the two conditions here. This becomes density. This ratio becomes density. Flow rate upon speed becomes density. Multiply by percentage, it becomes follower density. Okay, and from follower density, then we have a table to find out the level of service. Okay, you come back to this table. This is my percentage frequency. My speed is this much. Okay, and so you can see the table. They are using the posted speed limit. So you have to know the posted speed limit in any case, whether you have the free flow speed or you don't have the free flow speed. You need to know the posted speed limit to use this table. Clear? Okay. Now, step 1, step 2, step 3, step 4 and 5. 5, right? Okay. Data gathering, step 6. You need data, right? Okay, step 6. 6 steps. And this goes up to step 11. Okay, so there are like 5 steps which involve going from one table to another table, from one equation to another equation, which we are skipping. Okay. Okay, sorry.
Next structure. You said the next structure there.
He said it, now I will do it. Okay, no problem. No, next time I have to explain again. No, we will not. I know, I need everything people is okay. What is the first step? Tell me. What is the first step? Tell me. Tell me. First step.
Free flow speed.
Free flow speed?
See?
Second step. Okay, what is the first step? See, now we're wasting time. Okay, find out the flow rate. Okay, find out the flow rate. We have 752 divided by peak hour factor. Okay, tell me how much? Tell me. Flow rate divided by peak hour factor. How much? 800? Okay. Vehicles per hour. The second step is to find out the free flow speed. Okay. For free flow speed, is it given? It's not given. Okay. Do I have the speed limit? I have the speed limit. Okay. So I can, first of all, I will find base free flow speed. Base free flow speed was 1.14 into the speed limit. How much? 57. Okay. Now I will go to the speed, the free flow speed equation and find out the free flow speed. Okay. First of all, base free flow speed I know. I have percentage high vehicles given in the question. Okay, I'll come back to it. I need to know the A factor, right? A factor is either this value or this whole thing. Okay, this value or this whole thing. Okay, now this whole thing has A0, A1 and so on and so forth. For that I should know the vertical class. Okay, so we have the percentage gradient. Gradient is what? 0%. Okay, and the length is how much? Length is given 0.75 miles. 0%, 0.75 miles. Okay. 0.75 here. Okay, 0%, 1. Okay, so my vertical class is 1. Okay, vertical class is 1. See? So now you know it will not come in the exam. Right? Because everything becomes 0. Okay, so all this becomes 0. My A equals to what? 0.033. Okay. Okay. Factor for lane and shoulder width. Okay. How much was the lane width? Somebody open the question. 12? 12 feet lane width. Shoulder width? Huh? 6? Where is it? Okay, what else do I need? Okay, give me factor for lane and shoulder width. Zero, right? All factors are zero. Very good. Okay, what is the access point density? Huh? Access point density? No, I don't want it. Okay, access points. Do I have access points? I have my access points are 0. Okay, if I put 0 upon 4, it will be 0, and you have to take the minimum, so access point factor is also 0. Okay, what is my free flow speed then? Okay, just need to put the percentage of heavy vehicles here. Okay, this is 0, but you don't need this one as well, right?
Yes.
No, A is 0.033. You still need this one. Okay, 0.033 into percentage of heavy vehicles. So my free flow speed is how much? 56.9. Okay. Next thing is to find out the speed. Okay, can my speed be equal to free flow speed?
Yeah.
Huh?
Yes.
No.
ليش no? يمكن يصير. ما هذا ساعة تصير ساعة ما يصير. إيه كم الحين سؤالك لنا؟ دكتور كلام يصير please tell me.
800.
800 no كلام دكتور.
Okay. So now we need the M and the P value, right? Okay. Like I said, we have 1000 equations and 20,000 tables. Okay. But it's given in the slide. What the next slide? What is the value of M and P? How much? Yeah. 3.626 and P value? 1. Okay, what is the speed? Now this is the M and P value for speed equation. Okay, how much is speed? How much? 53? 53.7? Okay, then the next thing is to calculate the percentage followers. I need again the M and P. How much is the M and P for this case now? It's written in the slides. M negative 1.337 and P is 7524. Okay, so what is the percentage followers here? 67.7, and we will take it as percentage. Okay, follower density 0.677 multiplied by 800 divided by the speed, which is 53 point, how much was it? 8. How much? Okay, 10.1, my level of service is how much? Huh? Which column I'm looking at? My speed was how much? More than 50, right? Or 50? Speed limit. Speed limit was 50.
8.8.
Huh? The speed limit. The one which is given the 50, okay? Equal to 50 is this one. Equal to 50 is this one. And Z 10 point something, right? 10 point something is here. Level of service is D. Clear? Any questions? Okay. Okay, so these were the values M and P given for each thing separately, and these are the examples you should look at, okay, in the manual. Clear? Yes. Like the 345 theory. 345 theory. I finished 5 and 6. I finished 6 and
Between us and to the final, right?
Who?
That is the final. Theory. Theory.
Maybe. Maybe.